This is the Chapter 9 practice test walkthrough. Number 1. In this equation, which are the products? A plus B produces C. Well, the things on the left-hand side of any equation are called the reactants. Okay, so A and B are the reactants here. And the stuff that comes after the arrow on the right-hand side are the products. In this case, there's only one product, which is C. And that happens to be answer choice B. So the answer is B, but in the equation it's letter C. In a chemical equation, lowercase g in parentheses after one of the substances means that it is which of these? A solid formed from two ionic substances, released as a gas, dissolved in water, or produced from nothing. Well, produced from nothing, that doesn't happen. Dissolved in water is AQ, a solid is S, and G is a gas. So again, this is answer choice B for number 2. How many total atoms are there in 4 Fe2 SO4 3? So I like to work sort of from the inside out on this. So go into the parentheses first. Inside the parentheses you have 4 oxygens and 1 sulfur for a total of 5 atoms. Now those 5 atoms are multiplied by 3 on the outside, so that gives you a total of 15 in the parentheses, and then it's Fe2, so that's 2 more. So you have a total of 17 atoms in this compound, and then the coefficient of 4 means you multiply the whole thing by 4. So 4 times 17 is 68, which is answer choice D. What type of reaction involves one reactant and 2 or more products? So we're looking at something that looks like this. AB produces A plus B, and it could be ABC produces A plus B plus C. The key is one reactant, 2 or more products. That is always a sign that you have a decomposition reaction. Which type of reaction usually takes place in solutions and produces a solid, gas, or water? Well, decomposition certainly could produce a solid, gas, or water, but that's not what we're looking for. We're looking for double replacement. This is where you have AB plus, I'll say CD, and then your products are CB plus AD. Double replacement means that the 2 halves of the compounds trade place, and this usually takes place in a solution. Synthesis is 2 things becoming 1. Combustion is a combination with oxygen and some other substance. Number 6, what type of reaction is K plus Br2 produces 2KBr? That is the same formula as A plus B produces AB. That's going to be a synthesis reaction when you have 2 or more reactants and only 1 product. That's always a synthesis reaction. Which types of reactions can sometimes apply to the same question? Okay, combustion and synthesis. Well, combustion in one form looks like A plus O2 produces AO, or AO2 if you want to balance it that way. Synthesis looks like A plus B produces AB. So sometimes the formula for a synthesis reaction and a combustion reaction can look the same. Okay, single and double replacement don't look the same. Synthesis and single replacement don't look the same. Synthesis and decomposition are actually opposites of each other, so they can't apply to the same equation. Which type of chemical reaction would this be classified as? So here, if you look, you've got Al with hydroxide on the left, H2 with sulfate on the left, and on the right you have aluminum with sulfate, and you have hydrogen with OH or H2O. So this is where you have 2 compounds that then trade halves, and that's always called a double replacement reaction. Identify the type of reaction shown by this equation. So here you have HgO produces Hg plus O2. That should really be a 2 and a 2 to balance it out, but here you have the same formula we were looking at earlier where you have 1 reactant becoming 2 products. That is a decomposition reaction. Which type of reaction is this an example of? This is another case where you have iron and potassium trading places with each other. Both are in compounds on both sides of the equation, which makes it a double replacement. If iron was by itself and potassium was in a compound, and then potassium was by itself and iron was in a compound, that would be single replacement. You're not combining with oxygen here, it's not combustion, and you've got more than one product, so it can't be synthesis. What type of chemical reaction is this? Here you have aluminum as an element by itself. Iron is part of a compound on the left. On the right, you've got iron by itself, and aluminum has moved into the compound. That is the case for a single replacement, where you've got one element and one compound on each side, and the element that's by itself has traded places with one of the elements in the compound. What type of reaction takes place when propane reacts with oxygen to produce carbon dioxide and water? Well, if you wrote this out, it would look like this. Okay, and then CO2. I'm not balancing this right now. But the key is, anytime you have something reacting with oxygen, you're looking at a combustion reaction. Sometimes, again, that can also be a synthesis reaction, but in this case it produces carbon dioxide and water. That "and" means there's more than one product, so it couldn't be synthesis. That wasn't a choice anyway, but just to keep in mind, sometimes a combustion reaction can also be a synthesis reaction. Okay, we're going to balance this equation. First thing to do is take an inventory. We've got 4 phosphorus and 2 oxygens here. On the right, we have 2 phosphorus and 5 oxygens. Okay, so the first thing to look at is we've got an odd number of oxygens on the left, we've got an even number on the right, and that even number on the left is even, on the right is odd. So we've got an odd number on the right for oxygen, we've got an even number on the left. That number is never going to be odd, so we have to look at making this one on the right even. Well, the easiest thing to do here would be to double that, which gives us then 10 oxygens. It also doubles the number of phosphorus we have. So conveniently, that balances the phosphorus, and now we just have to fix the oxygen on the left. If we put a 5 in front of the O2, that gives us 10 on the left and 10 on the right. So the equation is P4 plus 5 O2 produces 2 PO2 O5s. Okay, let's take a look at this. We've got hydrogen. There's one there and one there for a total of 2. NO3. Anytime you have a polyatomic ion, you want to look to see if maybe you've got the same polyatomic ion on both sides, because if you do, you can kind of keep it together for tracking. So I'm going to say that that's 1 NO3 instead of 1 nitrogen and 3 oxygen. And then I've got 1 sodium, and I've got the other hydrogen we already counted. Then I've got CO3, but I don't have CO3 on this side, so I have to break up the carbon and the oxygen. Okay, now I'm going to count the right-hand side. I'm going to go in the same order. So hydrogen over here, there's H2, and it doesn't appear anywhere else, so that's 2. NO3, like I said, that's together on the right as well as the left, so I'm going to keep it together. That's 1. There's 1 sodium there. There's 1 carbon here. And then oxygen, there's O2 plus another O for H2O, and that's 3 oxygens. So it's already a balanced equation. You don't actually have to do anything to that. It's already balanced. C7H16 plus O2 produces CO2 and H2O. This is combustion reaction again. To tally up, I've got 7 carbons, 16 hydrogens, and 2 oxygens on the left. So 7, 16, 2. Those are pretty easy numbers to work out. On the right, I've only got 1 carbon here. I've got 2 hydrogens here, and I've got 2 oxygens there and another one here. That's 3. Oops, sorry, 2 hydrogens, 3 oxygens. Okay, so I'm going to go ahead and start. Remember, if you've got oxygen by itself, save it to last, because a lot of times you can kind of go back and fix things at the end with an element that's by itself. So I'm just going to start at the top and work my way down. I've got 7 carbons on the left and only 1 on the right. So if I multiply CO2 by 7, that gives me my 7 carbons on the left. Does change the number of oxygens though, because the 7 times O2 means I've now got 14 oxygens in this molecule, and I've got another one here, so that's 15 oxygens. Now I'm going to go down to the next one, hydrogen 16, hydrogen 2. If I put an 8 in front of the H2O, that would give me 2 times 8, 16 hydrogens. It also, again, multiplies this oxygen in the H2O times 8, plus I said I had 14 over here in CO2. So 14 plus 8, okay, now I've got 22 oxygens. So then if I go back to the right-hand side, I've got O2, I need to be 22, so if I multiply the O2 by 11, there's my 22. So your coefficient should be 1 here, so we don't write it, and then 11, 7, and 8. That balances out the equation. So use the activity series to see if these will take place, and then are they balanced or not. So will magnesium replace zinc in this single replacement reaction? Here's magnesium on the activity series, here's zinc. Magnesium is above zinc on the chart, which means it can replace zinc in the equation. So that will happen. Here's the balancing. There's 1 magnesium, 1 zinc, 2 nitrates on the left, 1 zinc, 1 magnesium, 2 nitrates on the right. It's already balanced. Next equation, will iron replace lead in this single replacement reaction? Well, where's iron on the list? Iron is here, lead is down even farther on the list, so iron will replace the lead. Anything above, higher on the list will replace anything below it. So now, balancing, 1 iron, 1 lead, 2 nitrates, 1 lead, 1 iron, 2 nitrates. It's already balanced. Now copper and iron sulfate. Will copper replace iron? Well, copper is a very unreactive element down here near the bottom. Iron is in the middle. So copper cannot replace iron. There's no reaction here. Okay, aluminum sulfate is often used in water treatment. Why is this so? Well, go back to the activity series, and aluminum is sort of above average in reactivity. It's above the middle, which means it will react with a lot of stuff. It'll bond to lots of stuff that's already in the water. When it does that, most of the time, aluminum compounds are solid. So aluminum will grab onto these things that are in the water, make them into a solid compound that you can then filter out and make the water more pure. So what we're really getting at is, depending on what you're trying to do, you may want more reactive elements or less reactive elements. More reactive elements are good for things where you want to form compounds quickly or make things latch onto each other. Less reactive elements like copper and gold down at the bottom, those are good for things that you want to be more durable and not last, like sculptures or money. Okay, that's going to get passed around, it's going to be out in the air, it's going to react or touch a lot of things, but you don't want it to react. So copper and gold are used for coins for that reason. All right, oldies but goodies, converting kilograms to milligrams. This is going to be a 2-step conversion. Anytime you have 2 prefixes, you need 2 steps. So start with what you've got, 5.69 kilograms over 1, then kilograms goes down to the bottom, grams, the base unit, goes on the top. This is always the middle part of a 2-step conversion. And then you have grams go down to the bottom and milligrams, which is what you're trying to get to, on the top. So multiply across the top. 5.69 times 1,000 times 1 is 5,690. Multiply across the bottom. 1 times 1 times 0.001 is 0.001. Now divide. 5,690 divided by 0.001 is 5,690,000. It's already the right number of significant figures because all those extra zeros are just placeholders. So you don't have to do anything else there. Electron configuration for sulfur, it's 16 electrons, number 16 on the table. So we're going to go 1s2, and we're going to go like this until we get to 16. 2s2, that's 4. 2p6, that's 10. Next would be 3s2, we're up to 12. 3p could hold 6, but I don't need 6. I only need 4 more, and that adds up to 16. 2 plus 2 plus 6 plus 2 plus 4 is 16. Last one. Complete the calculation of the correct number of significant figures. Well, 3.05 times 0.04620 comes out to 0.14091. That's the answer you get in your calculator. But 3.05 only has 3 digits, which means your answer can only have 3 digits. So we're going to find the first one, second one, third one. I'm going to round off at the 3rd digit. The next number is 9, so I'm going to have to round up. So 0.141 has 3 significant figures. That's your answer.